So let's look at this now. This is good news. This is these are the problem sets that go with the stuff we talked about last week. You're going to think that super quick, super easy. This is going to be just, they'll be done before you know it. Look at this example here. They want you to do, this is for the 7-3 assignment. These are what the problems are like. This is it. They want you to simplify an expression. Either you're going to do a product, or I didn't even bother with like the sums and differences. I maybe put one problem on the assignment, but those are so simple. I'm going to do the harder ones for you guys right now. We'll go through a couple of them, and then the rest of them are even easier. Where you're going to be doing either like a quotient or a product or a composition of functions. And I want two things from you. I want the simplified expression, which is like 7.1, 7.2 stuff. Okay, that's stuff we've already kind of worked on, talked about, properties of exponents. You're getting good at that though, and I think you're going to be fine there. Part 2 really is the new stuff. I want you to write the domain, okay, of this expression. Okay, so we could f of x over g of x. In fact, let's even, just so we can refer to that as one thing, let's say that the quotient of f of x over g of x, let's just call that h of x. Okay? So let's simplify this thing. What is that quotient? Call it h of x. Well, let's just find out. If I just stack f of x over g of x, I can just simplify and see where we end up. So we get minus 9x to the 5/4 over positive 2x to the 6/5. Okay? So what do we do?
Because you're flipping.
Okay, we want to try to simplify this. Now in this case, the 9 and the 2 don't simplify, do they? Okay, so, but the problem is, now we've got these x's, right? We've got to simplify the quotient of like bases. We know that when we take a quotient of like bases, we subtract the exponents. And 5/4 is bigger than 6/5, right?
Yeah.
And so this would go to the top this time, wouldn't it? Right? So if it's going to the top, that's great news. Then we're not going to have to worry about something being stuck on the bottom and having to rationalize a denominator, right? We might look at maybe one other example possibly where we have to rationalize the denominators just to get a little review of that. But in this case, because my x's are going to be stuck on the top, I can just apply that property of exponents, right? So I'm just going to get negative 9 x to what?
120.
How'd you get that?
Because
Well, what do you do if you divide like bases and the bigger exponent is on the top? You what? Well, I mean, we're going to have to eventually.
Like subtract it, yeah.
Yeah, subtract. So we get 5/4 minus 6/5, right? Okay. Divided by 2. So all we really have to do is just subtract those fractions. We're going to get a common denominator of 20ths, right? So we'll multiply by 5 over 5 and 4 over 4 and get 25 minus 24, right? 20ths.
Yeah.
Everybody see that?
Wait.
Yes, Clancy.
So what happened to the 2x?
Okay, so
What happened?
listen please. It's a good question. What happened to the 2x on the bottom? Well, this is what we did. We absorbed the quotient of like bases. Remember what our rule is. If we have a to the m over a to the n, and if m is bigger than n, we leave the base on the top, and we write it as a to the m minus n.
Okay.
So in this case, our base isn't a, it's x.
Okay, you don't have to rewrite it. Okay.
No. And so, and all this stuff right here, if we do the math, it just becomes 1/20. Okay? So we end up with negative 9x to the 1/20 divided by 2. Okay, that's the answer to part A. Okay, and we'll put that into Moodle and you can see how it works.
So it's negative?
Yes, it'd be right, negative, I mean, everybody sees that, right? This is just, that's nothing new. That's just properties of exponents and simplifying, right? Okay, but what about the domain? Now, this is the new stuff, but it's also the easy stuff. What's the domain of h of x? So remember, there's two kinds. We have to just look for restrictions. We want to look for places where values of x that don't work, that have to be restricted because they violate one of our two rules. What are those rules? Okay, we can't divide by 0, right? And we can't take, what? Okay, we can't take an even root of a negative number, right? So now, if we just look at h of x, at the simplified expression, which of those rules do we have to be concerned about?
Negative, positive.
Okay, yeah, there's no x on the bottom, is there? So the
No.
only one we have to really be concerned about is the even root of a negative number. Well, this is an even root, why?
Says it's even.
Okay, because the denominator of the exponent
Is
is even, right? So because the denominator is 20, it's an even root. And so we're going to look at the blue bubble. Everything inside that radical, inside that root, is what we have to be careful about. So everything inside that has to be non-negative, right? It can be 0 or positive, greater than or equal to 0. So restriction number, go ahead, question? No? So restriction number 1, based on the blue bubble, is this. We know that whatever's in the blue bubble, which is just an x, has to be greater than or equal to 0 because it's the argument of the even root. It's what's inside the even root. Okay? There's one restriction. Okay, but remember, as we talked about last week, it's not just what we get for our simplified answer, it's all the ingredients that go into that cake, right? It's all the stuff that we use to build that simplified answer. And what we use to build the simplified answer is this whole thing, right? Okay, and there's potentially a problem there if we look on the bottom. There's a great problem in calculus that we look at that's, you'll see it again in a couple years in calculus, but it makes sense to kind of think about this right now a little bit. It illustrates an important point that we're talking about. Where am I? Okay, we always look at this. In calculus, we look at this example where if we take the function f of x equals x, that's a pretty easy graph, isn't it? That's just a diagonal line, slope of 1, y-intercept of 0. Okay, what if we take the function, g of x equals x squared over x? What does that simplify to? What does that simplify to?
X to
X.
the 1.
Okay, it simplifies to x, doesn't it? So g of x simplifies to x, but if you graph that thing on your calculator, and we could do it right now, if I try to evaluate that function like at 2, x equals 2, I get back y equals 2. But if I try to evaluate that at 0, it says error.
Error.
Domain error.
Static
How come?
problem.
Because there's an x on the bottom, exactly. And so because there's an x on the bottom, we have to have the restriction on the domain that x can't equal 0. So even after we do the simplification, we still inherit that domain restriction, okay? And if we graph this thing, and we'll talk more about this in a couple of years, but if you graph this function, what you get is this line with what we call a hole in the function at 0, 0. It's not part of the function, okay? All right, so going back to this, then we have to do the same thing here, right? H of x, the quotient, is built from this function on the bottom, so we have to also say, are there any restrictions there? Well,
Yes.
yeah, there are, aren't there? Because now I'm dividing by a function that has an x in it, agreed? So let's make an orange bubble, how about? And the orange bubble is everything on the bottom. Everything on the bottom cannot equal 0, right? Now that's an odd root, so we're okay there, but there's still an x in it. And so if we set up restriction number 2 is that the orange bubble, 2x to the 6/5 cannot equal 0. So what are the steps we go through to solve that? I mean, what, divide by 2, right? And then I can do the fancy, I mean, we haven't even really talked about how to do this, but we can just finesse our way through this for now. By the end of the chapter, we're going to solve radical equations and we'll know how to do this precisely. But what's the only x value that could produce 0? 0. That makes sense? So the only value we can't have here is 0 from the second restriction. Okay? Now we got these two restrictions. We have to take the combination of both of those at the same time. In math, we'd say we're going to take the intersection of those two restriction. So how do we say this then? How do we say x is greater than or equal to 0 and x is not equal to 0?
X is greater than 0.
Greater than 0. So our domain for this function then becomes, here's the function, but the domain becomes x is greater than 0, right?
So that's just the domain, that's the answer.
So answer the second part is x is greater than 0?
Yep.
And the first one is because of the 120, right?
Yep, exactly. And so if we want to input that in Moodle then, here's, now you guys remember what I'll forget this. You remember what that is. So we get, they want us to separate the two parts with a comma. So the first one was negative, what was it? 9x to the 120th. Or I could write it as a 20th root of x if I want to. Either way, it doesn't matter. Over 2, good. And then we wanted, the second part was x is greater than 0? Okay. Okay.
Is this on yours?
What's that? Yeah, I got these built.
So there is no comma.
No, why don't you just do it on my assignment?
Oh, this is on my assignment. Yeah, sorry. I gotta get my homework done too.
I think it'd be better.
Do you think so?
Yeah.
Okay.
We just practice all of it.
Aha.
We just practice the test too. No, wouldn't that be nice if you like every day like, you would know, you just choose an assignment in the real world? That would be tested back to reality.
Okay, let's look.
I don't like reality.
I was playing with Sharon.
Okay, here's a good one. Yeah, I like this. This is a good one.
I do not like it.
Okay, let's look at one of these. Oh, you know what I want to do though? Let me do f of. Well, I guess that's okay. We'll do that. All right. So now here's the other thing I would ask you to do. Listen, please. Yep.
Is the domain, the answer for the domain part, is it always like x is greater than or less?
Okay. What the question is the answer for the domain part always like x is greater than or equal to? Well, a lot of times, but it also might be something like what if there are no restrictions? Then you just pull up this, you would enter, you go comma, and then to enter all reals, I just go to the symbol menu, and there it is. Right? That just means, what that's telling us, and that's the math way of saying that the domain is unrestricted. The whole set of real numbers would work. There's no restriction on that set.
So, how many restrictions are
Well, the restrictions are the ones that are imposed by those two rules, right? Okay, let's look at this example. The second example is another good one. This will give us a different kind of domain. Cameron, put that away, please. You need to really pay attention to this. Thank you. Okay, so this is asking us to do a composition of functions. They want to know if f of x equals negative 10x to the minus 1 and g of x equals 2x plus 4, what is f of x? G didn't even play a part in this, right? But this is where we're doing a function of a function, okay? So if we want to do, let's kind of see what we got here a little bit. So we know that, let me write this bigger so you can see it. We know that f of x equals negative 10 x to the minus 1. So what is f of a? Well, you can tell me. Negative 10 a to the negative 1. What's f of hand? Negative 10 hand to the minus 1. Okay, so what is f of x? Bingo. Negative 10 f of x to the minus 1, right? So we'd write then, let's do this in 2 steps. So we get f of x equals negative 10 f of x to the minus 1. And what's f of x? Negative 10 to the minus 1. Okay, so then we end up with this is equal to negative 10 times negative 10 x to the minus 1 to the minus 1.
Wait, why? No.
Okay, hold for just a second, Trent. I want to make sure I want to do this in a flow, and then I'll take questions. Okay, so what do we do with this? Now, there's a bunch of ways you can look at this. Listen, please. What does a negative 1 power mean? It just means it goes to the bottom, right? It goes to the other part of the fraction. But we could also, so you have the option here of either saying, well, f of x really just equals negative 10 over x. That's fine. You can write it that way if you want to. Or we could, alternatively, we could just take that negative 1 and distribute it to both parts. I don't know which way is better. They're about equally good. But if I distribute the exponent and simplify this, don't I just end up with negative 10 times negative 10 to the minus 1, right? Times x to what power?
X to 1.
To the 1. To the x to the negative 1 to the negative 1 is x to the 1, right?
Wow. Okay.
Right?
Yes.
Okay. Well, what's this going to be? What's negative 10 times negative 10 to the minus 1?
Negative
100.
Negative 100.
Well, that's like saying negative 10 to the 1. If I multiply like bases, don't I add the exponents?
Yeah. So just negative 10.
So I get negative 10 to the 0. What's anything to the 0?
It's 1.
1.
Wait a minute.
Listen, let me say that again. Listen, please. So we could, from an exponent perspective, we get the base, negative 10, to the 1 plus negative 1. So I get the base to the 0, and remember our rule of exponents. Any base to the 0 power is 1, right? It's almost easier, though, isn't it, in a way to just think about this as being negative 10 divided by negative 10, right? Negative 10 to the minus 1 is the same thing as just saying divided by negative 10, right? Either way you slice it, though, my answer is just x, isn't it? Right? So the first part of this in Moodle is x. Okay, that the simplified expression for that composition is just x.
Wait.
Okay.
Wait. So why do you divide it?
Okay, let me do this the other way, and that might. Here, let's do this. Well, what if we do? Let's do this.
It works on your calculator. Just try it.
Well, it does, but we don't need to calculate.
Wouldn't f of x, f of x just cause an infinite solution? Because you
No.
put the f of x into f of x.
It doesn't. You're just putting the f of x into that whatever that formula is.
I mean,
It just shows up wherever the x normally would.
is f of x, is that just always x? Should I end up?
Is f of x always x?
We did an example last week.
Yeah. Because I asked that.
Yeah.
Sorry.
No, it's not. Just the examples we've done have been. But yeah, it's not. It's a good question, but no, the answer is no. What if we write it that way? This might be easier to see. Everybody, that is negative 10x to the minus 1, right?
Yes.
Okay, so then if that's true, then isn't f of x just equal to negative 10 divided by negative 10 over x, right?
Yes, and you have restriction. Why?
Well, because what used to be an x is now being replaced by f of x,
But why would you put x on the bottom?
because that's our function,
It's just like saying that's
right?
Because it's to the negative 1.
Because it's to the negative 1.
Put it on the bottom.
Okay, listen, I'm going to say this one more time, but we're getting down to the end of the year where I can't tolerate anybody screwing this up for other people. So if you choose not to get this, that's fine, but you don't have the option of screwing off in class and talking and stuff. So shut up if you're talking and listen. Raise your hand. I want questions, but I don't want people talking. Okay, so this is just a different way of writing negative 10x to the minus 1. Maybe it's easier to see that. I like this way better, right? We just write it as a fraction. So in this case, f of hand is just negative 10 over hand. So f of x is negative 10 over f of x, right? Negative 10 over f of x. But what's f of x? What's that? The recipe for doing a composition of functions is whatever the inside function is in the composition, that's just going into the original where the x used to be, right? Right? So then if whenever we divide by a fraction, we just flip and multiply, right? So this just equals negative 10 over 1 times the reciprocal of the bottom, right? just get x. Okay, yes?
So technically, we've kind of been, well, not, but like, have we kind of been?
Oh, you guys have done this forever. Yeah, you've done composition of functions without calling it that forever, yeah.
So you're just changing the name and putting it
Yeah,
in
just-
fractions?
Right, we're trying to understand, you know, at a maybe a more theoretical level, how does this algebra work? I mean, you guys know how to do it because you know how to do algebra well.
So this is kind of like they gave you an equation and then like x equals 2, except now x equals the equation before.
Right. X equals a function, yeah, exactly. Okay, so we get back then, we get back for our, well, we're just going, oh, I guess I'm there. So we get back for our first answer, x. Now, what's the domain of x? Are there any restrictions on x?
Yes.
No.
X is
No
fine.
restriction.
So then we
So you
put
put
the
that
R.
R.
Okay, no even roots, no x's on the bottom. So the domain of our composition, the whole thing, is unrestricted, but we got a rule. Remember, what's the rule?
Isn't it earlier you got the x to 1?
X doesn't
Yeah.
equal 0.
No, I never had the
Oh, I
x. Oh, that's just plain old f of x, sorry. Right,
So
that's
we
just
just
f
put
of
in
x
R?
equals that. Right?
So we just do the R.
Okay, it's not going to be, but I want you to tell me why. If I take the function, if my composition is, I need more room. Yeah, I can do it there. Okay, so if I have the composition of functions, f of x equals x, sure, I have to look at the overall answer, but remember, I also have to look at the domain of the inside function, right? Because any restrictions on the inside function, I inherit.
And then the x would be on the bottom if you do f divided by f.
Exactly.
Sweet,
Right,
okay.
exactly.
I'm so confused right now.
Okay,
Wait, but technically, wouldn't you always have that if you're saying take that divided by that? Or no?
So the negative.
Like if you're trying to figure out f of x, wouldn't you always put that like f of, then the parentheses f of x equals, and
No,
then
but
your
they said
equation?
simplify the expression for us.
right. So we're simplifying it. See the difference? We're simplifying it,
Yeah.
getting a simple answer. But the point is, if there are any restrictions that occurred before we simplified, you know, if there are any restrictions on that function that we put into f of x, we have to inherit those.
Okay.
Think about it as like inheriting, like if you buy a house, if there were liens on that house, if someone, you know, then when you buy the house, you inherit those. You're financially responsible. Like if someone took a loan against that house and you buy the house, then you're responsible for paying back that loan. That's why you always have to check if you buy a house to make sure there are no liens on the house.
You mean
Lien, L-I-E-N, meaning there's some kind of a, you know what I mean, there's a loan against the house. And if you buy the house, you inherit those, right?
Oh, I didn't know about
I didn't
that.
know
If you have, no, that's true, yeah,
What?
that's true. That's why you always wanted, you gotta check that stuff.
See, we do learn.
You do, exactly. If you, like certain, for example, birds that have certain genetic defects will pass that on to their offspring. They inherit those problems just like this.
I like this way better.
You like this way better?
Yeah.
Just like that composition of functions inherits any restrictions from the functions that it's building from,
Okay, that
right?
makes sense.
Okay, so what about the plain old f of x? Well, remember, f of x,
Was negative 10x.
yeah, it was negative 10 over x. Are there any restrictions on that?
Yes.
Yeah,
Like x is 0.
0, yeah, right? X can't equal 0, everybody agree?
Yes.
Because the bottom can't equal 0, so therefore, even though our answer looks totally safe, right? We still have to have that restriction, x does not equal 0. Yes?
What about the original where it's negative 10x to the negative 1, and
Mhm.
x wasn't on the bottom, so then how?
Well, but it is. What is x to the minus 1?
Does it just mean on the
It's 1 over x to the 1.
even though when you, okay,
Yeah.
so if there's negative 1, then that equals 0.
Yeah.
And a negative.
Okay.
This is just maybe a better way of rewriting it so you can see that there's an x on the
Yeah,
bottom.
like there is restriction.
Okay, so then when we input this in Moodle, we gotta input the x and we need to input the restriction, right? So let me get rid of all this stuff, that's kind of messy. So how do we do that?
X, comma.
We would do x comma. Now, what do you think the best math, and this really is the best math and the right answer, the best mathematical way of saying everything's fine except that one number, 0. It's not equal to 0, right? So we would just say x is not equal to, which is on the operation menu right there. X is not equal to 0. And that's our answer. Okay?
Phenomenal.
Phenomenal. How about that?
How do you always get them right? Whenever I enter.
Okay, so now what do you suppose you would do? Listen, this is taking a little longer than I expected, which is fine. But let's make sure. I want to give you guys as much lab time as possible this week. What do you suppose would happen if you had, say, only two values of x that were excluded, but everything else was okay? Let's say we had x can't equal 0 and x can't equal 2. What do you think I would do?
X is
Write them out
greater.
separately.
I'm going to go down here to the operations menu, and I'm going to choose does it tell me? The logical and. Okay, that's the and. If you hover over it, it'll tell you. I want x does not equal 0, and, yeah, they all do. X is, look, if I hover over this, see, not equal to, right? Whoops, I got to put that in there, don't I? X is not equal to 2. If I hover over the R, what's it do? It tells me real numbers.
Wait, how do you know X isn't equal to?
Well, this exam, I'm saying hypothetically. What if there were 2? That's how you would enter it.
Okay.
Didn't that make sense? Because you got these 2 places where everything else is fine, but what are the 2 restrictions? Because those are the things we're really most concerned
And
about.
what is
So it'd be like
or VF? Or.
Or. That's an or statement. Yep.
So,
Will we have some like those with 2?
Eventually you'll probably have.
so if
Some,
x doesn't equal 0 and 2, what about the numbers in between?
Well, it implies everything else is fine.
Okay.
Yeah.
Because there might be, because I was curious if there might be some equations where it would mark, okay, numbers between this number and this number are not, cannot.
No, I won't. We're not gonna do anything that complicated.
Okay.
Okay. So next issue. Okay. Okay, I'm gonna pick the hardest one I can, and you'll see they're not that hard.
Yeah.
Oh, I just changed it. Yeah, that's okay. No, Clocks are so confusing, honestly.
I think it's slower and slower every time.
Like, it has numbers on it, so I even know how to cross clocks.
Oh, I don't know how to do clocks. Like I do, but it takes me a long time. Like I don't get one, oh, it's a quarter till. I'm like, quarter till what? Just tell me the time.
Just be like, it's 12. And I'll be like, it's a quarter to 2.
Okay, what about this? Okay, here's the other thing we talked about. Very simple, right? This is really simple. I mean, this is easier than the other stuff. They want us to find the inverse function given that original function. Okay, what's our recipe? 7.4. What's the recipe for finding the equation of an inverse? No. Remember the notation. Yeah, this is important. This notation right here, it looks like it's saying to the -1 power, but when you see it in that context, when it's like in the middle of an f of x, like that, in the middle of a function, that's telling you it doesn't have anything to do with exponents. What it's telling you is it's the inverse of that function. Okay?
So you just have to switch everything over from like,
Well, what was our recipe we talked about? Remember we said step 1, I'll get you started. Step 1 was we're going to rewrite the original function with a y instead of an f of x. So step 1, we just get this. Y equals 64 x to the 6th minus 19, and we got to include that with the restriction x is less than or equal to 0. So the domain has been restricted here a little bit. Okay, what's the next step?
flip the X and Y.
That's it. Flip x and y, and then we just solve the y. That's it. That's all you do. Okay, so step 2, this becomes an X, this becomes a Y, and don't forget the restriction. What does the restriction become now? Y is less than or equal to 0.
Oh,
Okay, you can all tell me, what are the steps I use to isolate Y? First, I add 19, divide by 64, and then 6th root, okay? So let's do that. So if we do those steps, let's combine all those steps into one. We're gonna get the Y by itself, and you told me I'm gonna get X plus 19 divided by 64, and then I take a 6th root, right? Okay, that's the same thing. I can either write it as a 6th root or a 1/6 power, but what am I forgetting?
Why is, oh,
If I, excuse me,
so why?
if I ever take an even root of both sides of an equation, what do I include?
Plus or minus.
Plus or minus. You gotta get that plus or minus in there. So we got plus or minus, right? Now, can this be simplified? Yeah, it can. X plus 19, if I choose to write this, let's go ahead and write it as a radical. That's just a 6th root of X plus 19. But on the bottom, I've got a 6th root of 64, which is what? 2. Okay, now what about the plus or minus? Here's the other part. Okay, look at this restriction up here. We're told that Y has to be less than or equal to 0. Okay, now if I take, this answer is positive, isn't it? If I put any value in for X, if I take an even root of any number, I'm gonna get back either 0. If I, the even root, 6th root of 0 is 0, but the 6th root of any positive number, those are the only kind I can put in, positive. This is telling me, though, that my answer, Y, has to be less than or equal to 0. So which of these signs do I have to use? I have to use the negative, don't I? Right? So my answer is that.
Wait, how did you get 1 over 6? Why did you 6?
Because I'm taking, well, look, I have Y to the 6th.
Yeah.
So I take a 6th root of both sides. I take both sides to the 1/6 power to undo that.
Okay.
Right, did everybody see that? If I have something like Y to the 6th equals, let's just say hypothetically Y to the 6th equals 64. Right, if I want to solve for Y, aren't I, by taking a 6th root, I'm really just doing this. A 1/6 power, right, and then those cancel. See, same thing, isn't it? Okay, with our properties of exponents. And I just get Y equals plus or minus 2 in that case, right? But now that's a different problem, that's an easier problem, right? Our answer is all that stuff. I can't simplify the top, but the bottom, fortunately, worked out to be a 6th root of 64 gave us back an integer. So you didn't have to wrestle with rationalizing denominators and all that stuff. So I kind of worked them out, so you don't have to focus on that stuff. Yep.
So why did the Y become X?
Because that's the recipe for finding an inverse.
You switch the Y to X.
You switch X and Y and solve for the new Y. And that, whatever you get for that new Y, that is the inverse of the original.
And so it was negative
Because of this restriction.
which,
Because in the original problem, the restriction was that X had to be greater than or equal to 0. So the restriction, when I flip the X's and Y's, that becomes Y is greater than or equal to 0. Okay? That's the hardest one on the assignment by far, right there. The other ones are really straightforward and much easier than that. But that's not too bad, right?
wait,
Yep.
is that our answer?
That's the answer. Yep. Yep.
So if we entered the X plus 19 over 164, whatever, into the computer and we had to make
It would give you, I think, probably half credit and say, okay, it's equivalent, but it's not simplified. Yeah. Okay? All right, last issue then. Last issue, I'm gonna have you do on the homework assignment, the graph problems, I'm almost done, they're super cool, but they're not done. So I'm gonna have you do just a couple, really minor, I'll add like maybe 2 or 3 problems total, where I want you to just, in fact, I may just have one. I think I'll just have one problem that's kind of a natural one. Listen, please. Where I want you to determine what are the graphs, which graph goes with which inverse. Okay, now here's how you tell though, right? When we're looking at graphs only, what's the relationship between a relation and its inverse?
90 degrees.
Okay, there's 2 ways to look at it. They have reflective symmetry over the line y equals x, Or remember the trick I showed you? If we have something like,
Rotate.
yeah, we can do this, right? If I have, let's say I have, this is my function. And I want to find the graph of the inverse. Remember what we do? We take the whole thing, we rotate the whole graph 90 degrees counterclockwise about the origin. So this would become what? It look kind of like something like that if I rotated it, right? And then I reflect it over the y-axis and I get this. Right? And then that would have that, I didn't draw it very well, but that would have that symmetry if I drew it correctly. That should have been up higher. But you get the idea?
Yeah.
Okay. Have a good lunch.